Oh my God, it's already time for my favorite report. This is the parameter instance report. And in here, we are doing a deep dive into all of your parameters, all your instance parameters, which ones are empty, which ones are useless. And this is going to be the biggest data mess. And this is the perfect report to solve all of it. So let's dig into this report. It's extremely important and extremely powerful. So the first thing we can see here is we can only look at a certain model if we want to just focus. We can also just look at a single category like walls or doors, etc. And here we have what's called a parameter class. So parameter class is very important to understand. Built-in parameters are parameters that are part of Revit. You can get rid of them. We're going to see some here like edited by, image, comments. You can improve the data quality inside of it, but you can never get rid of comments, even if you find it completely useless and irrelevant. The next type of parameter is going to be the standard parameters. So standard parameters are parameters that are added in individual families. So you need to, for example, go inside of a door, add a parameter for the thickness of the door. Now, if you have 30 doors with that parameter, you need to open 30 families and get rid of that parameter. So it's more painful to clean up. Then we have the project parameter. So project parameters are parameters that are applied to every category that is selected for them. They're easier to clean up. For example, if you say walls, floors, and doors should have a fire rating, any doors, floors, and so forth is going to have that fire rating, and vice versa. You can completely remove it or add it to a category, or you can completely delete it in one go. Now, those are scarier to delete because usually it's hard to kind of get a visibility into whether that parameter is used or not, hence this report. Final parameter is less popular. I think it came in Revit 2022 or something like that. Global parameter is just something that's applied to the entire project in a different manner. Okay, furthermore to these 4 category classes, for instance, parameters, we have parameters that are shared or not shared. Well, all of the shared parameters come in through the report, so that's no problem. And here we see them, they all have a shared GUID. So if you're working with shared parameters, keep in mind a lot of parameters have the same name, but they are not the same parameter, right? For example, I think this report has 60 different length parameters. They are not the same. So if you're working with shared parameters, it may be worth even doing a different slicer that looks at the shared GUID so that you can really only work with that parameter and not all of the other ones that have the same name but are not the proper shared parameter. All right, here we have a slicer. If you want to focus on one parameter at a time, you can go in here. And then we are going to be looking at the 3 matrices. So the first one is the parameter name, and we have data like how many elements is it affecting, how many values are in there, what's the percentage of values that are filled, how many distinct values, how many families are affected, how many types are affected, and whether it's built in, whether it's a string, or what type of parameter it is. So usually you can sort this in a couple of ways that are going to give you different insight. The basic way is to sort alphabetically. This is going to show you parameters that have the same names or perhaps misspelled. It's not going to prioritize the data, but you can kind of just go through alphabetically, especially if you have any kind of naming standard. This is where we're going to see whether it's properly applied or not. So here, for example, there's a number sign before everything. You know, that's kind of a terrible naming standard, but at least it's applied consistently. Then you can also sort by the count. So the count is going to show you the parameters that are affecting the most amount of families. And really, this is where performance comes in, right? If you have a parameter that is in 2 million families and it's always empty, get rid of that parameter. It serves no value, and it's huge in terms of the amount of data that it's filling in. Now, of course, we cannot get rid of built-in parameters, so it may be worth just turning this off since you can only improve the data of built-in parameters. You can't get rid of them. So having turned off the built-in parameters, we see all of these extension buffers. We see down here that the value is always empty. There's a single value and it's empty and it's 0% filled. So this is garbage. You need to get rid of all of these garbage parameter. And down here we see, for example, item space description. So here we see there's a lot of errors, misspelling, inconsistent spelling of the data. So that's a problem with the data quality. And it's only 33% filled, right? So then we can go in the table below. This is going to let us know which categories and families the parameters are in. So let's drill all the way up to get some insight. So we see that these parameters are only ever filled in the MEP model. There's 8,000 of them in the architecture model, but they're never filled. Let's go down one row. Here we only have one parameter selected, so we can just keep going down the next row. Here we see which categories this parameter is applied to and whether it's actually filled or not. So it's in air terminals, never filled. Cameras, never filled. Communication devices, never filled. It's only used 66% of the time in ducts. So it seems that perhaps we need to fill it properly in ducts or get rid of it. And when we go down here, we are now looking at the MEP model, and it's still, once again, really inconsistently filled. And we see some ridiculous stuff here, right? Like it's applied to 2 levels. So basically, a really old BIM manager came in and over-applied this project parameter without really thinking. They probably just selected all and went about their day. So obviously, a level is not going to have a space description. That's a conceptual item. So at this point, the BIM manager needs to determine, do I get rid of this parameter, or do I actually select categories where it's useful and then perfectly fill it out? Not to mention, you're going to need to standardize the data in here, because clinic and clinic is not the same, and College of Medicine and College of Medicine and College of Medicine, those are not the same. Now notice a very important thing here. It's very subtle. It says display value CS, and that means case sensitive. So by default, Power BI will not use case sensitivity. This is how the data usually comes in. It's going to merge, as soon as it's got the same letters, it's going to merge data that has different casing together. So we added an extra special column that's called Power BI case sensitive. And you'll see it on a lot of important things. So the element name, the face filter, the family name, the family parameter name, the family parameter value, the family instance parameter name, the family instance parameter value, and so forth. So when you see PBI case sensitive, that's what it means. And when you're looking at things like the name of the family, the name of the parameter, the name of the face filter, it's extremely important to have case sensitivity. And we see why here, because otherwise we would not have detected this misspelling of the data. When you don't use the same case sensitivity, it's not the same data, right? Okay, let's keep going in here. We're going to sort by percentage filled. So this is going to look at the data that's 100% filled, and we can kind of keep going down here, and we're going to start to see the percentages drop all the way down to potentially 0%. Now, this is a huge model, so there's just a lot of scrolling in here. It's actually taking some time to, pull in more and more and more and more data. Okay, so we see here it starts going from 100% to 99.9%, all the way down to 0. And once again, it's not because a parameter is 100% filled that it's actually valid. For example, this element here always has a value of 0. So that's why we color it in red, because it's very likely completely irrelevant and is bound for the garbage bin. Let's do one last poke at table down here. So if you keep expanding this, you're going to see the model, the name of the parameter, the category, the family, and the type. And you can also see the last or the first example value. So we see here it's 0, 0, 0. We know that there's 175 and 981 zeros. So if we scroll down here, we're going to see the vector inline version 2 is the only one with an actual parameter value for the self-noise power level at 4,000 hertz. Okay, so this is when we are looking at all of the parameters. It's a lot of data. So here we have what's called a format navigator, and we can click on this to look at only the partially filled parameters. So out of those 2,000 plus parameters, is going to get rid of all the ones that are 0% filled and all the ones that are 100% filled. And all of a sudden, we're really honing in at this weird little in between. There's 172 parameters that are partially filled. But look at this, it affects over 2 million values. So in here is really a good opportunity for cleanup. So you can look, for example, at sheet numbers and then realize, okay, well, there's only one that doesn't have a value. So let's go fill it in or not. Same thing for refrigerant type. You can determine which one doesn't have a value. Now, when you're going to be messing around with these different tables, if you want to do more than one selection, it's important to hold the control button. So if I want to select just this one here, I'm going to hold control before I click. That way it's not going to lose the selection back here of refrigerant type. It's going to keep both filters at the same time. And now we see that it's the Revit ID right above here that is being shown. Speaking of Revit IDs, we actually have a very important table up here called the combined Revit IDs. And whenever I have a selection in Power BI, it's going to aggregate all of the Revit IDs in here. So what I can do is I can simply copy the values and inside a Revit, go into the Manage tab, go select by ID and paste all of my values. And all of a sudden, I'm going to have all of those elements selected. And what I can do is isolate them. And once I've isolated them, I can start fixing the values in there or doing whatever modification is required. Now, keep in mind, right now, this is the architecture model, right? But if I go in another parameter, it's possible that it's in the MEP model. So it's not going to be able to select things in the MEP model. If I want to do that, I need to close the architecture model, open the MEP model, and then I can have that selection or send it to that team if it's a different team. Okay, so let's move on to the next filter here. We're going to go to parameters that are 100% filled. So we have close to 2,000 parameters that are 100% filled, and we see how many, the kind of worst case scenarios up here. You can kind of turn off the built-in parameter if your goal is to destroy parameters and do some cleanup, because you can't get rid of built-in parameter. So this is going to give us a more accurate analysis. Okay, so now we are looking at parameters we can actually affect more greatly, not the built-in. And so when we go through here, we're going to see all of the values, all of the elements that only have a single value. So that's usually a red flag. So the Skanska cost item value is always at 0. Therefore, that is a garbage parameter. It should go to the bin. And a very simple way to speed up your analysis. And so here we see all of the parameters that are 100% filled, but only have one single value is kind of an indicator of garbaginess, if you will. All right, our last state is going to be empty parameters. So once again, not really worth looking at built-in parameter unless you want to go in and add that data. And look at this, we have 446 parameters. And that's 2 million values. I believe the total values is 8 million. So 2 out of 8 million is completely useless, completely empty, and ready for the garbage bin. So if we take all of these parameters and we get rid of them, it's going to really speed up our model. Not to mention, it's going to add a lot of clarity in our data, because when we select an element, we're not going to be looking at 30, 50 empty parameters and wondering which one is actually good, who did or didn't do their job. We're only going to see data that matters. So this is the Instance Parameter Audit Report. It's extremely important for your performance and is going to allow you to do a very intense audit of your data that's impossible to do any other way. So I hope this was helpful for you and you can really speed up your project, add a lot of clarity, and do an intense analysis with this. So I hope this helps you make your projects more efficient and more comprehensible for your workers, for the owners, and for all your collaborators. Have a great day. Cheers.